My name is still Jeroen van der Gulik, and I still want to talk about software development and software architecture. So in order for us to do that, let's look at some of our examples, some of the greats in our history. So we're going to play a little game, so it's not only awkward for me, but also for you. So who is this? Who can take a guess? First programmer? Not entirely true. It's not Bruce Lee. But nice try. So this is Grace Hopper, one of the original programmers, not the original programmer. As you can see, she still works with tapes, because we didn't have anything else at that time. She's responsible for the compiler, so kind of important. And also she's responsible for machine-independent programming language, which sounds kind of normal for us today, but in her time, everyone programmed the actual computer. So, interesting story, she went to her boss and said, I want to invent a new programming language where we can, use actual English words. And her boss said, don't be silly, computers don't understand English. So yeah. So, who's this? Not Bruce Lee. Anyone want to guess? So this is Dennis Ritchie, one of the original writers of the C programming language and of the Unix system. Also kind of important for history, right? So again, not Bruce Lee. Who is this? No one? So this is Alan Kay, who is greatly attributed as being the grand or the father of object-oriented programming. You're not participating very well. So another try. So if anyone has the right answer, I will get them an elephant. Does that help? Just bribe the audience, right? So who's this? I see you have to do this alone. So this is Edsgaard Dijkstra. Why is he famous? The Dijkstra algorithm. Very good, very good. What else? It's Dutch. Yes, that's why he's famous, exactly. So, and now we have all these great people, but the greatest one of all, who is this? Bruce Lee, yeah, right? So, in this talk, I'm going to try and prove to you that Bruce Lee was actually one of the original software architects. In order for me to do that, we'll have to go back into time. And we have to go back into time when I went to college, which is about 7 million years ago. And when I was in college, I wanted to be the best software programmer and best software architect in the world. I wanted to know everything, right? I wanted to be the best of the best. So I read all the books you could find. Design, Petrus, Pragmatic Programming, Mythical Man, Code Complete, Head First. I read them all, right? Because I knew when I read all these books, I had all this knowledge and I would be the best. So I had this huge library of books that I read. And interesting fact, by the way, if you want to read a lot of books, there's a very good site called DevBooks. In this site, they maintain a list of all the most recommended books on Stack Overflow. Now, the #1 recommended book on Stack Overflow is Working Effectively with Legacy Code. Think about that for a minute, what this says about our industry. So I read all these books, and I was in love with these kind of diagrams. These were great, right? UML was my ubiquitous language, basically. If you could just express everything in a UML diagram, it would be amazing. I could just write it down, and all I had to do was just build it, and it would be perfect. And it would be just right. I was a strong proponent of solid principles, right? I mean, my programs would be so solid, they would be solid like the Chinese wall. You could see them from outer space. That's how solid they would be, right? But then I started to learn and read a little bit about Bruce Lee and the way he approached things. And one of his saying is, notice that the stiffest tree is most easily cracked, while the bamboo survives by bending with the wind. And this always stuck with me. Because I wrote all these amazing software programs, and I went to my clients, and my client said, do you remember that thing I told you about that was never going to change? Do you know that requirement that wasn't important? That little bit of tiny information that actually was a really big deal? Yeah. So that thing we need you to change, the thing that was not a big deal, that is a big deal, and all the other, whatever you made is not important to us. So my perfect build diagram was, shattered. My software program was horrible, and it was not maintainable, et cetera, et cetera. And I felt very bad, because I thought, well, I made like an entire diagram, everything was so beautifully laid out, but it wasn't good enough. And I felt the same way when I was playing a computer game called Diablo. Most of you won't know it. Anyway, in Diablo, you level up, you gather stuff, you gather items, you gather levels, et cetera, and you get better and better at the game. So I'm a little bit of a masochist, so I play the hardcore version, which means that if you die in the game, you have to start all over again. So all the days, weeks, months, years of work you put into your character, gone. And I felt the same way when I lost my character, when yet another software project ran wild, basically. But over time, when I lost more and more characters, I felt less bad about it, oddly enough. It's like, another one died, another software project failed, whatever, right? That's kind of bad as well. So the reason why that happened is because whenever you start a project, this is your plan, right? And this is what happens. And this is like a universal truth, right? So Bruce Lee captured that in life is never stagnation. It is constant movement, constant change. Because most software projects basically work like this. They're more like a chimera. I mean, they're like a compound, menagerie of all sorts of animals. There's a bit of a dragon in there, a lion, a goat, some wings. And that's because software projects change over time a lot. They go left, they go right, they go up, they go down. A lot of them go back. And the reason for this is that nobody writes perfect software the first time. That's the biggest lie we keep telling ourselves. Like, we cannot do upfront design because we don't know everything yet. It's not going to be perfect. Well, except this guy. But there's only one of him, right? So, let's talk about architecture. What is a software architect? Anyone want to guess? Apparently not. So to me, a software architect is a software expert that makes high-level design decisions and choices about the technology used, the stack used, including stuff like coding standards, et cetera, right? And as we all know, all architecture is design, but not all design is architecture. So let's talk about architecture more. So what is this? Church, very good. What's the function? Okay, what's another function? Make money. Okay. So this is a church, and people come here, gather here, and do prayer stuff, right? So let's try another one. What is this? What is this? Okay, so what's the goal? Okay, well, actually, there are two goals, but okay, what's the function? So put a bunch of people together and watch some kind of ball game, right? So this one is a little bit harder. What's this? Library, very good, library. But we needed a little bit of a agenda to explain that it's actually a library, right? So we look at these architectures, and they're pretty clear, even though we're not experts on stadiums and libraries. I think so anyway, I'm not. But we can pretty much figure out what it does, right? So Bruce Lee said, those who are unaware they are walking in the darkness will never seek the light. So let's do this exact same experiment, but let's use software. So what is this? Who can tell me which language this is? Ruby. Any specific form of Ruby? Rails. Very good. What does it do? Okay, that's a little bit of, like tricky question. I mean, we all know it's Ruby on Rails and it uses MVC structure. So let's look at the MVC triads, right, to see what it does. So we have an app, we have some controllers, helpers, models, and views. Now everybody knows or is taught that all the business logic is always in the model, so we can probably figure out what it does by looking at the models. So here we go. So who knows what this does? Except suck. So let's help you a bit. So we have, let's see. It's like an issue tracker. Very good. Very good. So actually, it is an issue tracker. If you look at the controllers, which tell us everything we need to know, because we have a GANs controller and a files controller, obviously this is an issue tracker. So this is Redmine, open source project that does project management and issue tracking. And I know what you're thinking, but this is Ruby. We don't do Ruby. I mean, that's not fair. So let's try again. What's this? Language. Wow. Laravel, very good. What does it do? Things, Laravel things, okay. Well, okay, let's again try and figure out what this do by looking at MVC triads, right? So we have an app. It has stuff in it, commands, console, includes library. It has Ninja. Holy moly. It has Ninja. Amazing. So let's look at Ninja first, because Ninja. So yeah, Ninja has data tables, import, intents, mailers, notification, payment drivers, presenters, repositories, serializers, and transformers. Obviously Ninja, right? But I know what you're thinking. Ninja are notorious for hiding their intent, so obviously they're hiding their intent here. So let's look at the models again. So we have account, pretty good. We have bank. We have invitation, invoice. We have subscription, task. Anyone want to guess? Ninja invoice. Very good. The first one who actually get it. So this is a personal, invoicing piece of software, which you can see obviously by the controllers. So this is my problem when we approach software as software architecture and software development. When I open up a legacy project, preferably not written by me, I have no clue what it does. And usually the README doesn't help me either. So to give a very simple example of this, let's build a house the way we would build software. And I will use Symfony as an example here, just for people who say, well, everybody hating Laravel. Okay, so this is a house bundle, because it's Symfony. So we have a command, go to bed and get dressed. We have some controllers. We have bed controller and clothes controller and stairs controller. We have entity instead of model because reasons. So we have cement and floor and wall and a bunch of stuff. And we have some services like change room service. And we have sleep service. So simple question. How many floors does this house have? That's kind of bad house, right? If you don't know how many floors it has. How many stairs does this house have? No idea? Does it have stairs? Is it an apartment, maybe? Do we care? That's also a very good question. So if I would approach this, if I was, built actually a house, it would probably look more like this. So an actual house, it has a first floor and a second floor, and in the, on the floors it has some rooms, and in the rooms it has some stuff in it. But the way we build software now, if we would do that, as actual builders, it would be like, okay, let's put all the walls over here. Let's put all the doors over here. The windows over here. And yeah, a bunch of stairs, let's put them here, right? This is how we build software. This is our architecture. So what have we lost in the last few decades about keeping it simple? Why don't we just, write it down the way it's supposed to be? Did we forget this fundamental rule? So I came across this notion, which always stuck by me. The junior hard codes it, the media creates an abstract factory for it, and the senior hard codes it. I don't know who I can attribute this to, it's probably Bruce Lee. So when I was reading about Bruce Lee, it stuck to me that his life time or his entire life journey very closely relates to how software works. So when Bruce Lee was younger, about 12, he went to school. He grew up in Bangkok, and there were a lot of gangs and rival gangs in Bangkok. And they would just beat random people up just for the fun of it, because that's what they do. So Bruce Lee was, beat up a lot as a kid. And he learned to fight that way. So he was on the street, and he got jumped, and he took everything he could find. Like if there was a rock on the floor, he would use the rock. If he could kick someone, he would kick. If he could punch someone, he would punch. But basically, everything in his surroundings he started using just, to not get beat up by gangs. But when he got a little bit older, around 16, he thought, well, this fighting thing isn't working out that well. There's probably people who actually know how to fight, right? So maybe I should learn that. So I went to this guy, a very famous teacher called Ip Man, and he became a student in Wing Chun, which is a subsection of Kung Fu. So he went to rigorous training. He studied all the different martial arts there are. So snake and crane, or more popularly known as in the West as crane, tiger, every form of Kung Fu you can think of, he studied, right? And he studied them rigorously and to the book. The funny thing was, though, that every sensei, every teacher he came across, all told him the same thing. Our Kung Fu is the best. If you know our Kung Fu, you can solve any problem you encounter. This is kind of weird, because there's like, I don't know, thousands of versions of Kung Fu, and everyone said the exact same thing. And this is kind of how we approach software. If you do functional programming, this is the best paradigm. If we do object-oriented programming, this is the best paradigm. If you do design patterns, these are the best design patterns, right? If you use these religiously, everything will be fine. And in my opinion, that's pretty wrong. So it doesn't matter if you use PHP or Ruby or whatever. I mean, they all have something in them. So he studied them all, even drunken men Kung Fu. And I'll leave up to your imagination to what that, relates to. The only thing that was different about Bruce Lee than the rest of the students was that Bruce Lee was not a full-born Chinese guy. He was a Mughal, or half-blood, as they say. His father was an American. And actually, you weren't allowed to teach Kung Fu to non-Chinese people then. So he had to train a lot of the times alone, like smashing into a rock or into a tree, etc., etc. So while everyone was very indoctrinated by the Kung Fu mentality, Bruce Lee had a little bit of a different outcome or a view about the entire Kung Fu world. So at some point in his life, he became what we call enlightened. He saw that all these different forms of Kung Fu have something useful in them. And at some point in time or some certain situations, you can use that Kung Fu to solve a problem. And also what he realized was that in every Kung Fu, people approach you straight on, and then you do a move, and then you win. But in real life, he thought that, well, maybe I got jacked from behind most of the time, and that doesn't help me at all. So he came up with this. Use only that which works and take it from any place you can find it. And he took that to the extreme and designed his entire own version of Kung Fu, which basically means grab all the things I find useful and put it together. And he called it Jeet Kune Do. Roughly translated, Bruce Lee's Kung Fu, which is not true, but I like to hope so. So the core rules of Jeet Kune Do are three basic rules: efficiency, directness, and simplicity. Efficiency is an attack which reaches the target in the least amount of time with maximum force. Directness, doing what comes naturally in a disciplined way. And simplicity, thinking in an uncomplicated manner without ornamentation, right? So he summed it up in this: the less effort, the faster and more powerful you will be. Now, I'm not going to say that Bruce Lee was the first agile coach ever, but you could make that point. So let me introduce you to Bruce Lee-driven development, also known as Jeet Kune Do. We already have TDD, we already have DDD, BDD, so now we have BLDD. Right? So, first rule of BLDD. Begin at the core. But what is the core of your application, right? What are we talking about here? So the focus on the core here shifts to whenever you start something new, a new project, a new problem space, don't think, well, I'm going to need PHP, and I'm going to need framework X, and I need like Memcached, and Redis, and MySQL database, and Elasticsearch, and all these things don't do anything to solve your problem. They're just tools that we use to fix a certain problem. So just focus on what you're actually trying to solve. And to figure out what that is, there's a very good book by Eric Evans called Domain-Driven Design. I strongly recommend you read it. And one of the things it talks about a lot is communication, what they call the ubiquitous language. And to give you an example how that affects your project, a raise of hands. How many see a white dress? How many see a blue dress? So this is the core at what software communication is a problem of. We can all both talk about the same thing, but mean different things, right? That doesn't mean one of them is wrong. It just means we have a different view on them. So the lesson learned here is that effective communication is very hard to do. And Bruce Lee said this: in order to taste my cup of water, you must first empty your cup. And what he means by that is, whenever you get a problem in front of you, don't just start thinking about solution immediately. First, talk to whoever has the problem and try to find out if it's the actual problem or it's just they think that that's the problem, right? And you can only do that if you empty your own cup, because else you all have these pre-solutions that you're going to try and steer the conversation to. So the most important lesson here is listening, right? Second, recognize the value. What is the value of what we're trying to do? So I'll give you a very simple example. As a Kung Fu master, I want to travel fast to dojos so I can prove I'm the best, right? Now the focus and the value is here in travel and fast, right? So if we would build this, and we say, well, a car is very fast, so we're going to build a car, the first 3 steps of that process, we don't achieve any value. We only achieve value at the end, right? Whereas if we take this approach, where we first see Bruce Lee on a skateboard, and then on a step, and then on a bicycle, he still gets to travel, only the fast part comes later. But we have instant value here, right? So when the value goes up, the project is probably going to succeed. So always keep asking yourself, what is the value of what we're trying to do? What is it actually what we're trying to do, right? I'll leave you with this piece of wisdom. Great software today is often preferable to perfect software tomorrow. So I know what happens a lot in these cases. So you build those 4 stages, right? The skelter and the bicycle. And then a new guy comes in, looks at it and says, why didn't you just build an airplane, right? Because that travels the fastest. But this is what we call insight afterwards, right? 20/20 vision. So the key to immortality is first living a life worth remembering. We first need to get to that point before we can even consider something like an airplane. Because as a first step, it's way too expensive, right? So, next one. Use the simplest, most direct approach first. And I mean it in the most literal way. So, find X. There it is. Sometimes the easiest and simplest solution can be good enough. It's easy to change, easy to extract, easy to refactor. So try the direct approach first, right? You don't know if you need anything more complex than this. To give you an example what it looks like, if you have 3 balls going down a ramp, most people think that the top one will be the most efficient. And most people will think that the bottom one will be the slowest. So let's find out. Ooh. As you can see, the top one is actually the slowest, right? So, next rule. Change is inevitable. We talked about this before. We cannot, see the future. We cannot abstract things away if we don't have all the information. Premature abstraction is the root of all evil. So, you should write your code in a way that is easy deletable. And I mean that quite literally, right? Because if your code is deletable, it's self-contained, it's decoupled, it's all those good things we want. And if you need to change your code, adapt what is useful, reject what is useless, and add what is specifically your own, right? So let's talk about one of, in my opinion, most less understood principle. Let's talk about dry. So who of here does not know what dry means? Okay. So dry is an acronym for don't repeat yourself, right? And it's closely aligned with the single responsibility principle, but that's a whole nother story. So what we say is if you have some piece of code, it should just be that piece of code that's responsible for a thing, right? Don't have like 7 different things in your application that do the same thing. So the most easiest would be, I don't know, a helper class that formats a date time, something like that, right? You don't want 17 different things formatting and you just want one thing. But is this true in all occasions? So let's look at a real life example. Let's say you have a product you want to sell. And you have a sales team that wants to sell the product. And they have potential customers, right? They're not customers yet, they're potential customers. And these customers have specific territories. We're talking about a global, I don't know, eBay, Amazon thing. So there's a lot of points of sale here, there's a lot of opportunities. What is the information that a salesperson needs from this customer and this product? Well, specifically for the product, the price, the sell price, maybe some how do you call it, some deduction he can give you to make the deal from the customer. He probably wants to know like a profile that the customer is in, so he knows a little bit what the spending budget is, et cetera, et cetera. So the wishes of someone who's in sales about a customer and a project is very different than someone who is, for example, in support. If you're in support, you have the customer already. So you don't really care about the profile anymore. You care about whatever he bought, what is the warranty on the thing? Is it the specific firmware version that he runs, et cetera, et cetera? Is he a very good customer? Like, does he always pay on time? Stuff like that, right? And the product is the same thing. Like I said, warranty, we don't care about the selling price. It's already bought, right? Has it previously been defect, et cetera, et cetera. So even though we have customer and product in our application, and this is just 2 use cases, they have very different needs. So my answer to that is, do repeat yourself. So we keep dry. But do it with intent, right? Optimize for the specific use cases that you need them for. And with this bit of thing is, delay any major decisions about these kinds of optimizations to the very last moment, but no later, right? So, final rule, experiment. This is a bit of a controversial one. Warn you up beforehand. So try different experiments when you're building something. And the reason for this is usually most models are wrong, but some are useful. And we are interested in the useful ones, right? So there's a technique that you can use. It's called small controlled experiment, where you do like one little thing and you do it for a certain amount of time. And then you discuss with your team or with the company if it's a positive or a negative outcome, right? Does it help us or not? And if it's positive, it's most likely that you keep it. And if it's negative, you don't do it again, right? But you need this environment where you can experiment, because if you're training to be a Kung Fu master, you probably want to start training at this age and you want to have an opponent that's also of the same age, right? Because it's kind of mean to get something to be a Kung Fu master starting like this. Now, there was a story recently where some junior developer had straight access to the live database and accidentally threw the live database away. This. So, remember though, mistakes are always forgivable if one has the courage to admit them. Like, we need to make mistakes to learn, to grow, to get better. So your organization should provide that safe space, right? So, resume. The most important parts about Bruce Lee-driven development. Kind of spoiled it, didn't I? So, begin at the core, recognize the value of what you're doing, use the simplest, most direct approach first, change is inevitable, and experiment. So, aren't we just exchanging some set of rules for another. No, because Bruce Lee said, a goal is not always meant to be reached. It often serves simply as something to aim at, right? It doesn't mean we need to strictly do this. It's just try them out, see if they're useful, see if they help you, and then use more of it or less of it. So I talked in the beginning about all the books, and this is one of the most influential one, in my opinion. Design Patterns, Element of Reusable, Object-Oriented Software. What about these patterns, right? Should we just burn all these books, forget about them? That would be a little bit harsh. So Bruce Lee said this, obey the principles without being bound by them. So keep using all these things, just be wary of when you use them, right? So if you're interested or want to learn about this, how do you start? How do you start being a BLDD advocate? Well, Bruce Lee said this. If you want to learn to swim, jump into the water. On dry land, no frame of mind is ever going to help you. And I feel this is very much true in software. We talk about a lot of technological stuff and we have a lot of discussion, but actually building something is usually the easiest and best way to learn. So I'll leave you with these thoughts. Don't get set into one form. Adapt it and build your own. Let it grow. Be like water, my friends. Be like water. Thank you.